We're going to talk about auditing overhead irrigation systems. And I'm not a great irrigation person, even though I've spent a good bit of time working on it. It just rains down here in Mobile all the time. And so it's really difficult to do irrigation trials down here. Well, but this is pretty important work. That is knowing how well your irrigation system is performing. And that's because we use a lot of water. We're putting about a half inch or more per acre of irrigation a day. That could be around 14,000 to 20,000 gallons easily. So that's a lot of water that's running through those nurseries every day, especially on the larger nurseries. And we use a lot of water because we're growing in pine bark, which is, the perfect growing mix, growing substrate out there, but it doesn't hold water very well, and because of that, we have to use a lot of water. We also use controlled release fertilizers because we're putting so much water through there that nutrients can get washed out very easily. So we use a coated fertilizers that release based on temperature, and they will slowly release fertilizer, making it available to the plants all the time. So proper management of water is important. A lot of people don't pay a lot of attention, even though we're pretty good stewards of the environment. But water is a finite resource. We have droughts here in Alabama. We are typically, though, very blessed with rain and groundwater. There's also environmental impacts to be aware of. There's whether it's eutrophication of streams, where we're pumping a lot of nitrogen and phosphorus through runoff into our watersheds, causes fish kills and other problems. But sometimes a little more important, or what catches our attention, is the potential benefits of managing our water correctly, like fertilizer savings or reduction in disease pressure. One of the things that a lot of people have a hard time wrapping their head around is, the water holding capacity of a container. A container is like a sponge. It only holds so much water. And I've heard folks say, I only water every other day, but I water a really long time, and that's not really how it works. Because that container, like I said, it's like a sponge. It's only going to hold so much water. And if you go over that water holding capacity or container capacity, that's when you're going to start leaching. Now, we want it to leach a little bit, all right? But when we're leaching a lot, more than 20%, we're losing fertilizer. It's just getting washed out of the pot. Typically, what we want is for whatever we put on, we want 20%, 15 to 20% of that coming out of the bottom of the pot. And that's called a leaching fraction. So if we water too much, we're going to we risk root disease. And then we also have the potential to be flushing a lot of our fertilizer out of the container. And you can see this is a study one of our students did, Claire Croft, back in 2019, looking at how that leaching fractions, how much water is getting leached out of the pot compared to how much is getting put on. It's several different leaching fractions and the nutrient losses associated with that. And you can see it's linear. The more we leached, the more fertilizer we lost. And you can see this with the EC, or your fertilizer salts. The higher the leaching fraction, the lower the EC. So that means there's not a lot of fertilizer staying in that container, where we're just washing it out all the time. Claire also did a really cool evaluation. We don't like to use the word audit, but it was an audit for nurseries across Alabama. We looked at about 9 nurseries over 2 years in South, Central, and North Alabama. And we audited them based on their distribution uniformity. So how uniform their sprinkler systems or overhead irrigation systems were. We looked at their irrigation times and a bunch of other factors. But you can see here in this figure, the orange bars are the distribution uniform. That's how uniform their systems are. And you're really shooting for about 0.8 or 80%, which I haven't really seen one hit 80% yet, but that's the goal. But really, you want to keep it between 60 and 80 for distribution uniformity. Most of these are, but I will say once you get below 70, I think you're getting pretty bad. And you can see several of these are below 70. The clear bars are the black bars with no filling. that's the irrigation runtime. So ideally what we'd want is a high distribution uniformity and a low runtime. And you can see the first 5 nurseries are doing okay. The distribution uniformity on 4 and 5 is not great. But then you get over to 7, 8, and 9, and they're watering a long time. Now they may not be putting out a lot of water. I'm not sure. But running your system for 2 hours, that's a long time, especially number 8 there, where you can see they have a poor distribution uniformity and they're running it a very long time. So a lot of water is getting wasted in that case. And you can also see here, this is the leaching fraction. So how much water is coming out of the bottom of the pot. And you can see the range on those. We got our irrigation run times, and then those red bars is, the spread of those leaching fractions. You can see they're pretty wide. So a lot of these nurseries, their leaching fractions anywhere from 20 up to 100%. So they're losing a lot of water out of the bottom of these pots. It's very variable too. That's what this is saying, is there's a lot of variability in the uniformity in these irrigation systems. So how's your system stack up? One way to check that would be through measuring distribution uniformity. This is not it's not a great system, but it's what we got to work with. Basically, you're going to put out a lot of measuring cups, and you're going to measure how much water goes in each cup over a given area. So the stuff you'll need is, we just use solo cups. We're going to number them, and we kind of put it in a grid-like pattern. You're going to need some sort of measuring device that's graduated, preferably if it has milliliters would be great. If you maybe a graduated cylinder, or you see here we have a calibration pitcher. You use a calibrated sprayer. These work very well, but you're going to need to measure that water. You can place the cups. You want to put that out in a kind of an even grid. It could be as big as you want it to be. You can put as many cups as you want out, but you really need to have that number, at least 16 cups. And no matter how much you put out, it needs to be divisible by 4, right? We have these spread out pretty far here. I think really you would want to concentrate those 16 cups within a 4 sprinkler type area, between 4 sprinklers to really get a real good accurate number. So you're going to put these cups out, and you're going to run your irrigation for a normal irrigation cycle, which you would normally do. And then you're going to measure that water in each cup. You can also do this by weight if you don't have a measuring device. You can weigh each cup. So you can see we have these kind of unsorted on the left-hand column. So we have our sample, our cup, and then we have the measured amount in each cup. So once you have that, you can go and you're going to sort it then. You're going to sort it from smallest to greatest of the amount that you caught in each cup. The next step is you're going to take the, I'm sorry, I had the wrong picture here. You're going to take the lowest quartile, the lowest 25%. So that's going to be my first 4 in this case, because I have 16 samples. My first 4 measurements, and that's my lowest quartile. So I'm going to take that lowest quartile average over my overall average, and that's going to equal my distribution uniformity. So in this case, I was at 31.6 for my lowest quartile, and then 51.7 for my total average there. And it gave me a DU of about 61%. Not real hard. It doesn't really give you a good idea of the whole spread across the whole block. But this is kind of what we have to work with at the moment before anything better gets evaluated. So interpreting the data, if your percent distribution, you want it to be 80% or greater. But again, I haven't seen one over 80% yet. 60 to 80% are okay, but could be improved. I'd say if you're over 70, you're doing pretty good. If you're below 60, you really need to start checking things out, maybe even below 70. Check your nozzles, check your water pressure. How is wind affecting that? You may have unmatched precipitation rates across sprinklers, and we'll talk about that in a second. You may not have head-to-head coverage. So make sure those sprinklers, you're picking the right irrigation heads where you're getting overlap. We call it head-to-head coverage. You want a little bit of overlap if possible. And really, ideally, you would talk to maybe an irrigation company where they have a designer that could help you out because they do this all the time. And considering the importance of this, I'm going to go to a pro if possible. So mass precipitation rates. This is something I see a lot with impact sprinklers. So you can see here, most impact sprinklers are going to put out, a certain amount of water based on a nozzle. All right. So if you don't match the nozzles, you have what's called unmatched precipitation uh, rates. And so that means each of those sprinklers, whether it's on a full circle, a half circle, or a quarter circle, they're all going to be putting out, in this case, in this example, 12 gallons per minute. So I'm going to be putting out 12 gallons per minute in that area surrounding that 360 degrees of that sprinkler. Or if I got it on a quarter setting, I'm still going to be putting out 12 gallons per minute with that nozzle, but now I'm on a quarter of the area. So I have a lot more water going out per square foot with unmatched precipitation rates. So you can see on the figure below that one, this is how it should be. I should match my nozzles based on the whether it's a quarter circle, full circle, or a semicircle, half circle. So in this case, if I had a full circle and my nozzles rated for, or my sprinklers rated for 12 gallons per minute, if I'm going to have a half circle on the side of the bed, I need to get a nozzle that's going to give me half of that. And then if I have one on the corner, I'm going to need one that does a quarter of the maximum that sprinkler can put out. And you can see if you don't have matched precipitation rates, you're going to get a lot of variability in your distribution uniformity. And this is mainly I'm talking about with impact sprinklers. So you can see here, this is, if you would imagine, all these dots are irrigation heads. And so in this case, we're going to say a full circle from that middle irrigation head. I'm getting head-to-head coverage. I'm putting out 4 gallons per minute. All right. If I have a semicircle with unmatched, 4 gallons per minute, and then a quarter circle, 4 gallons per minute. So that's a lot of water on a smaller area. I've got a quarter of the area, but I'm still putting out the same amount of water. Well, if I've matched, I need to reduce that down by 4. So I've got 1 gallon per minute for a quarter for a matched, 2 gallons, or 4 gallons. You can see this is kind of how it shakes out if you were to zoom in on an area and look at your how many gallons per minute you're getting in these areas where these sprinklers are kind of overlapping. You can see when it's unmatched, it's all over the place. I got all from 3 all the way to 9, and it's a pretty big spread there. Now with mass precipitation rates, you can see that curve will be kind of smoothed out a lot. I've got a lot of 3s in here, for example. It's not a lot of variability here. So just matching your nozzles with the throw of that sprinkler is very important in your distribution uniformity. So some BMPs for irrigation design. Match precipitation rates, use the right nozzle size. You want to make sure you get head-to-head coverage or maybe a little bit of overage from that. And I would get help from a professional. If I'm switching into or building a new system, I'm calling one of the guys at one of the irrigation sales folks, and I'm going to use their engineer and want to get it done correctly, just to make sure, just because I have a lot of money at stake, water is very important to the nursery, and making sure I have that irrigation design correctly is really important. Also, choosing the right head. Not all irrigation heads are created equally. This is a recent paper that came out last year with some guys at UC Davis, Spinelli et al. There's a little URL code if you want to check this paper out. It's a really good paper. And he checked out 10 different overhead irrigation sprinklers, and he looked at their distribution uniformity. And you can see, I kind of summarized this in this figure here, and there's a lot of difference, between these different nozzles. This is the Hunter MP rotator. This is where it has multiple streams of water, really good mass precipitation on this one. A lot of these are kind of similar designs. You've got a couple of impacts down here that are a little bit lower. Then you have your wobblers, which are pretty high as well. And a lot of people I've seen are switching over to the wobblers. But your sprinkler selection is really important too in making sure you get good uniformity. And wind plays a big role in these too. I mean, you can see, you've probably seen wobblers or something that's got a lot of high pressure and a very small droplet size. Wind can really impact your distribution uniformity depending on that droplet size. If you want to learn more about doing this process, we've got a detailed guide through the extension fact sheet. You can go to aces.edu and just type in nursery irrigation, will come up, or you can use this URL code. So the next question is, how long do I water? And this is what you would do to kind of know that, to get an idea of that. You could use a procedure called leaching fractions. And that's basically the proportion of water that you applied versus what's leached from the container. So you have what's leached over what you apply. And you're looking for about, like I said earlier, 15 to 20% leaching fraction. So just a example of how, if you started using this technique to monitor how long you should water your savings. So this is Saunders Brothers. They're big into IPPS. They heard a great talk on leaching fractions, decided to implement it at their nurseries. This is a while back. And so just by monitoring their irrigation using leaching fractions, or excuse me, monitoring how long they should water using leaching fractions, they had pretty significant savings over a year's time at their nursery, about $83,000 worth of savings just by switching to leaching fractions. So it's got a lot of potential. One of the issues a lot of people are concerned with is that it's labor intensive. You got to do it every few weeks and make adjustments, and it's not exact. It's not an exact science, but it does give you a good idea. So if you were wanting to do this procedure, determine the leaching fractions, some materials you would need is, again, let me back up. There's two ways to do this. One way is volumetrically, where you're measuring the water in like a graduated cylinder or some sort of measuring device. And the other way you can do is by weight. And so for the sake of brevity, we're just going to talk about measuring the water volumetrically. But you need a capture container. So this container is what's going to go under your pot. It's going to capture the water that's leached. And you got to have some way to seal that up. If it's not a tight fit, a 3-gallon pot that's got smooth sides fits really well into some 5-gallon buckets or 3-gallon buckets. But if it's got a corrugated or ribbed side, there's a lot of opportunities for water to leach in there from the sides. So in that case, we'll use something like saran wrap or shipping wrap and wrap it around those pots to create sort of a seal. And you need a graduated cylinder or some sort of measuring container to do this. But you're going to select 5 to 10 plants. The more plants, the better. And you kind of have those evenly distributed within the irrigation zone. And then beside each plant that you set up with this catch pot underneath it, you're going to have another pot of the same size, and you're going to line it with a trash bag. All right. And the purpose of that pot is to see how much water was applied in the same area as your test plant. So then you're going to run your irrigation for your normal irrigation cycle. So what you're normally doing, and then you come back 30 to 60 minutes later after the end of the irrigation cycle. And you're going to collect what came out of the bottom of those pots, and you're going to measure it. And you're going to take those numbers, you're going to calculate a leaching fraction using this formula here, where you have whatever came out of the bottom of the pot over what came into the empty pot. So what was applied, and that's going to you're going to average that. It's going to give you your leaching fraction. And again, we're shooting for about 15 to 20% leaching fraction. Here's just some example data. You can see our input. This is how much water we caught in the empty pots with a garbage bag or a liner in it. This is what came out, the output's what came out of the bottom of the pot. You see I have a 0 in here. And sometimes if I have an outlier that something's weird going on, I may remove it within reason. So I'm going to average those. I got 36% leaching fraction. So that means I probably need to dial back my irrigation time in a little bit. I'm leaching too much. I'm losing some fertilizer. So how do you calculate the run times? There's different ways to do it. Here's a formula that I like, where you have, you can see it here. You take 100 minus your actual leaching fraction over 100 minus your target leaching fraction. And you're going to multiply that times your irrigation runtime. And you can see here we use the same 36% at a 30-minute runtime. I had a desired leaching fraction of 20%. And using this formula, I know I need to back it down to about 24 minutes. And you should really, if once you do that, give it a couple of days and check it again, because there's sometimes you may overshoot and put it too low. Again, this is not an exact science. And you may run your plants a little too dry, so it's important to go back out and check it in a few days. Then you can let it run for several weeks before checking it again. Now, occasionally you have some weird stuff that happens and it just makes your brain explode and you can't figure out what's going on. For one, is you don't leach any water, which and it's odd. It may be some pots. I see this especially in the fall when we start getting kind of dry, especially down here in the Mobile area. We get a lot of rain throughout the summer. And I feel like that kind of keeps us topped off a little bit. Well, then we get into the dry fall and we're kind of losing that rainfall and we start getting dry pockets because we don't know what's going on. We're just assuming our irrigation is enough, it's adequate, and we start getting some hydrophobic pockets in there. In these cases, we can either get channeling or we don't leach enough water. And sometimes, in some cases, this really will blow your mind, is you leach more water than was applied, and it doesn't make any sense. But I actually had somebody call me about that a couple of weeks ago. And in that case, your canopy architecture can impact your leaching fraction. So some plants may have a vase-shaped type of a canopy architecture where it actually catches water and funnels that water back into the pot. In those cases, you could get more water leached through the pot than was applied. It can throw it off a little bit. And then in some cases you have, more prostrate growth, and it can kind of act like a dome and kind of deflect water from going into the pot, and it may give you a little bit of lower leaching in that case. But this is a great publication here. It's a little bit older. It's from the renowned Ted Bilderback. He's a great nursery extension specialist in North Carolina. And he's got a really good presentation on file. You can access it through this URL code. And it really goes into a lot of detail about measuring irrigation systems. Here's just a setup we had for leaching fraction. You can also do this, like I said, by weight. And there's a procedure for that. And I'll show you a publication for that here in a second. So here you go. Here's our leaching fraction publication. You can access this. It shows you both methods and gives you detailed examples of how to calculate your leaching fraction. Just some other great publications out there if you want to learn more about irrigation and watering your crop. Great one from Tennessee State University, Virginia Tech, and then again that one from Ted Bilderback, which is it's an old one but a really great resource. Also, University of Florida has a lot of YouTube videos on this, and you can go to their channel, click on the videos button. You can access it from this URL, and they have a lot of information on managing irrigation, whether it's distribution uniformity or monitoring crop nutrition. A lot of great information on these how-to videos from University of Florida. Well, that's about all I have on irrigation